I'm going to talk about EIP-7732 or ePBS, and it has two names. One is Enshrined Proposer Builder Separation, and it's also known as Execution Payload Block Separation. So I hope by the end of this presentation, you have a better idea what this actually means. So I'm just going to go quickly through the things that I'll cover. I'll just say a few words about me. I'll go about what is MEV. I'll mention how Ethereum blocks are built today and how Ethereum blocks will be built after ePBS. I'll go through the benefits of ePBS, the current status, and hopefully there are some questions at the end. So my name is Stefan, and I'm a senior blockchain protocol engineer at Consensys. And I work on one of the consensus layer clients, Teku. So if you run a node yourself, then you're probably aware of the consensus clients, execution clients. So I work on the Java implementation, which is Teku. And also as part of that, I'm considered to be an Ethereum core developer, which is around 180 people. And it basically comprises of client teams, the execution teams, Geth, Bezu, Nethermind, and the consensus layer clients like Prism, Teku, Lighthouse. The researchers, DevOps, testers, and basically everyone works on the layer 1 protocol. So I'm going to start with a quick overview of what is MEV. So MEV stands for maximum extractable value, and it basically refers to the maximum amount of value that can be extracted while block production. And this means that changing the order of transactions, excluding transactions, including transactions, and some examples are sandwich attacks, front running, back running, and basically anything that can be exploited like decentralized exchanges. Like one example is when there's like a meme coin or an NFT, there's a lot of traffic, there could be a lot of opportunity for MEV. And validators basically can use the MEV Boost software to connect to a marketplace of block builders, and they basically choose the block with the highest bit. And around 90% of the blocks on Ethereum are built using MEV Boost, and that's quite a big number, but because it makes sense, like there's a lot of financial incentive to run MEV Boost, that's why every validator is running it, pretty much. And one figure is the MEV extracted on Ethereum from September 2022 to June 2024 was 526,207 Ethereum, which is around $2.4 billion. And here you can see at the bottom right, there was, for example, one validator got lucky, and he received 200 Ethereum. So this doesn't happen that often, but it's just one of the incentives why validators run MEV Boost. So a quick introduction how block building works today in Ethereum. So you have the consensus layer client and the execution layer client, which are connected to the mempool, which is basically user transactions. And every time a validator needs to propose a block, if they have chosen to use MEV Boost, which we saw that it's over 90%, they connect to MEV Boost, which basically connects to the builders via a relay. And the relay is like a centralized entity, which basically acts like an intermediary between the builders and validators. And this is required because relays and builders, they're off protocol. So you need some sort of middleman to do the communication between builders and validators. One analogy in life is like brokers who users connect to in order to connect to foreign exchanges. So you have builders, searchers, which basically submit transaction bundles to builders, and then builders, they submit their bundles to relays, and the relays, and through MEV Boost, validators connect to relays, and they choose the highest bits. So that's how it works at the moment, and we'll see in the next few slides how ePBS changes that. But the important thing here is to remember that relays and builders, they are not part of the protocol. So also I'm going to go over a little bit of like how slots in Ethereum work. So if you don't know, every 12 seconds there is an Ethereum block. And the first 4 seconds of the block is currently preparing the block, which means that the validator needs to code the execution client, get the execution block, which also means that MEV boost needs to be coded, and then the relays need to be coded as well. So, and also the consensus block, which contains the validator rewards, any withdrawals. All of this is comprised in these 4 seconds that need to be delivered. Usually it happens in the first second because there needs to be voting. So the voting happens in the next 4 seconds. The next 4 seconds, basically, validators vote on the blocks that they have received over those 4 seconds. And then because there are millions of validators, you need some sort of aggregation. So the aggregation happens at the 8th second, so that the next block can contain the votes in an aggregated manner. Yeah, so this is basically how it works now. And you can see that there's a bit of inefficiency because a lot of the work happens in the first 4 seconds, where the consensus layer client and execution client, they need to do a lot of stuff. And it's not very scalable. So yeah, I will go now how Ethereum blocks will be built after ePBS. So you can see now that basically relays and MV boost would be obsolete in the design. And builders, essentially, they become part of the protocol. And essentially, they will be staked entities as well. And all the payments between the builders and validators, it will be done trustlessly. So they can, now they can trust each other. So they don't require that middleman of the relay, which is also removes one other centralization part of Ethereum. Otherwise, everything else would work the same. Searchers, they will search the mempool and they will submit bundles to the builder. And then all the payments then will be done on the protocol rather than off protocol, like how it works right now. So this is the 12 seconds after ePBS. So you have the first 3 seconds, and these times they can be modified. Right now we're doing some research what are the best optimizations. Like these 3 seconds, they could be cut down to really 1 second even, because right now the all the validators needs to do is just to create a consensus block, which is very fast, and there will be basically the builders, they will submit bits at the beginning of the slot to the validator, and the consensus block would contain the bit, but it wouldn't require any transaction to be run. This is delayed until later in the slot. So basically the block production is very fast. So the attestation deadline changes to the 3rd second, and that could be changed. And then you have the aggregation happening in the second 6. And then also, the builders, they need to broadcast the execution. So that means that at the 6th second, the builders, they should have, they should basically broadcast the payload that the block's bit is for. So that basically allows these 2 things, like the consensus block and the execution block, to be done async. So this allows for a lot more scalability. And at the 9th second, there will be another voting period where basically validators vote for the payload timeliness, that they make sure that the builder has done its job. And basically at that point, the validators, they need to run the transactions, the execution transactions. So it gives them a lot more time to do that. Yeah, so I'll go over the benefits of ePBS. So one benefit of ePBS is the decoupled responsibilities. So it separates the consensus duties, the beacon blocks and the blobs from the execution payload logic. So that means that these things can be done in parallel, and basically it allows scalability. One other benefit is a trustless payload market. So validators are able to sell their rights, payload rights, without relying on any intermediaries relays. And the payment guarantees, they will be done on the protocol. And this basically allows for more decentralized, permissionless MEV ecosystem, since anyone can take part now being a builder. They don't have to rely on relays. I mean, I still imagine the builders in the market today would still be the majority, but I think there's a more opportunity for more builders to get involved without that reliance on relays. Also, there is an improved network liveness and stability. So by separating the consensus from the execution means that consensus blocks can still finalize even if there is a problem with execution payloads. I mean, no transactions will be executed, but at least the consensus layer could continue and finalize. And basically, it also means that the validator windows are extended and the bandwidth usage is optimized. And that allows basically for layer 2 scaling, which is one of the goals of Ethereum, is to basically, ePBS provides additional time for blob data dissemination across the network. So instead of right now you have like 4 seconds, you have like 9 seconds. And that means that there could be more blobs across the network. And yeah, it's a critical improvement for rollup throughput and data availability guarantees. So these were the benefits. So the current status right now of ePBS. So ePBS has been selected for inclusion in the Amsterdam fork, which is the fork after Fusaka fork, which will happen towards the end of the year. So Amsterdam fork is scheduled for, it's not yet scheduled, but it's going to happen at some point next year. We had a DevNet with Prism, which basically uses some of the ePBS specification, and we were able to finalize. We saw here that there have been some ePBS stress testing, and that means that the gas could be increased. And that shows like how good it is for scalability. And I've included some links to the EIP itself. We have a branch on Teku for ePBS, and the specification is already there for the fork. Yeah, that's pretty much it. Those two.